All right, so yesterday we left off here. Okay, we're actually going to combine a couple of biomes into this one kind of description here. So that would be temperate, deciduous, broadleaf evergreen, and sclerophyllous forest biomes. So these two here are kind of the Mediterranean one. Okay, temperate deciduous is what we're going to be most concerned with. Okay, deciduous means the trees do what every year? Right, they shed their leaves every year, so that's deciduous. Okay, and there's a lot of deciduous forests. It says only 9%, but I mean, when you look at the northern hemisphere, a lot of the northern hemisphere would have at least at one time been temperate forest. Okay, urbanization and the Industrial Revolution took care of a lot of those trees. Okay, it is a heavily altered biome due to urbanization and growth. Okay. Now, the key, let's say, factor for, or component for any forest biome is regular rainfall. Okay, so tropical rainforest, regular rainfall. Okay, temperate rainforest, regular rainfall. Temperate deciduous forest, regular rainfall. Okay, there's not an extended dry season. If you're going to grow a forest, okay, you then at least need regular rainfall. Even if it's low, okay, and the plants are adapted to that, the trees are adapted to that, it still has to be at least fairly regular. All right, so we can see here that month to month, it's pretty regular. You sure in June, July, and August, it's at its highest. I mean, that's natural. It is a mid-latitude or temperate biome, so we would expect to get a little bit more during those months. But there isn't any month where there's almost no precipitation. Okay, so that is kind of the big thing. And of course, you see the temperature line is a bell curve because this is a mid-latitude biome, so the tilt of the Earth is going to cause seasons, okay, to be present here. Usually, though, we're not looking at an extended, super cold winter. Okay, we'd be looking at more of a mild, tolerable winter, okay, with regular snowfall. All right, so warmer temperate areas characterized by mild winters, moderate precipitation, nearly constant all year, no extended dry periods. That's the big thing for climate. Okay, so if we're looking at a climate graph, that's what we're going to see. Okay, questions on the climate for those? All right, now vegetation, okay, it's going to be the deciduous trees, so oak, beech, hickory, okay, birch, hazel, sycamore, maple, okay, and that is all dependent on where you are in the world. Obviously, the further north in North America you go, okay, the more maple you're going to get, okay, because that's more of a colder, tolerant tree. Okay, if you go a little bit further south, then you'll get things like the birch and the sycamore, okay, hickory and oak. Okay, those are more of the more southern types of trees.
Will we have to know the specific types of trees for the test? Or
I might have it in a description, but it's certainly not something you have to memorize.
Yeah, we just need to know whether or not they're deciduous. Like.
Yeah, but I mean, if it's in there, it helps, right? So, no, I'm not going to say, hey, list all the trees that grow in this. No, I'm not going to do that. But knowing that, you know, maybe recognize a few of them, probably a good idea. Okay. Okay, and then if we're looking at more humid zones, or let's say borderline between temperate and tropical like you would have in the Mediterranean, okay, then those are sclerophyllous forests, and they are going to be a bit more drought tolerant. Okay, the rainfall is still going to be reasonably steady, but it's going to be lower, right? So you're going to have things like olive, okay, lots of olive trees, okay, sessile oak and pine. Right? And that's okay. It doesn't mean it's not a deciduous forest, okay, but it is a sclerophyllous forest and still kind of fits in there. It would just be more of a warmer climate for those. Okay, so like tropical forests, there is layering, probably not up to 5 layers, but more like 3. Okay, you have your undergrowth, understory, and canopy.
Do we have to know them all like separately, like on the test?
No, I'm not gonna. If I ask about one, it would be the deciduous. Okay, that's kind of why I'm combining them here. They are very similar except for one. Okay. Competition for light's a big factor because if you're in the canopy, you're shading out the things below you. Okay, so light's a pretty important factor there. And obviously, the trees in the deciduous forest biome are going to lose their leaves each year before winter. Okay, in the more sclerophyllous stuff, it's going to be more pine and even sometimes palm. Okay, you'll see palm trees sometimes in that one. Okay, Soils are going to be rich and loose, okay, and that's because they're made of leaf litter. Okay, the topsoil primarily is a layer of mulch and humus that is the result of decomposing leaves from the shedding year after year. Okay, so it does make them fairly loose. It can make them a bit acidic, okay, simply because a lot of that decomposition is going to produce a little bit of acidic conditions. Okay, and oftentimes the high rainfall can wash away some of the nutrients, but you're always getting that decomposition of the leaf litter. Okay, now for the animals, okay, you're going to have, a bit longer food chains because you're going to have, obviously insects and rodents and things like that, and you could have birds and smaller predators as well as larger predators, okay? So you could have short food chains where you have a big predator like a wolf or a bear, okay, and they're going to prey directly on moose and elk and deer, okay? Whereas you could have food chains like these where there's birds eating insects, owls eating the birds, okay, and then a lynx eating them, okay? Or you could have more of a typical food chain where you've got squirrels and mice, which can be directly eaten by the lynx, or the lynx can eat the fox and the weasel after they've eaten the mouse, okay? But they're a little bit longer because there are some smaller animals involved, okay, that can lengthen the food chains, but there are also going to be short ones. There's a pretty good mix of different sized animals in that biome. Okay. Unlike the tropical rainforest, because they can't walk around on the ground, right? All of these animals can because it's accessible. Okay, chemical cycling, again, it's a more northerly biome, so it is going to be slower, but there's a lot of moisture retained, there's a lot of shade, and that can lead to good conditions for fungi and bacteria, okay? So at least when it's warm and they're active, they can really be doing the job. But as soon as the cold hits, obviously they're going to stall and decomposition will slow. So it's not like a tropical rainforest, but okay, it's reasonably quick because the conditions for decomposition are present.
For the animals here, can you go back to the animal slide? It said that animal life is far more restricted in terms of diversity.
Right.
So that means like not much diversity.
Well, I mean, it's more diverse than some of the biomes we've gone over, like like a desert or something like that,
yeah.
Right? So you're in diversity. I mean, there's a lot of different types of animals,
yeah.
Right? Maybe not numerous. Maybe there's not a lot of each type,
yeah.
But there's more types. That's what diversity means. Yeah.
Mm-hmm.
Okay, so like I said, chemical cycling is going to be fairly rapid, and you're going to see just those conditions, moisture, shade, okay, things like that are going to help for that to happen quickly. All right, the taiga, okay, or what we often call the boreal forest. Okay, about 9% of the Earth's land surface, and it is probably now becoming more of a human-affected biome. Previously, it was not, because it was in areas that were very rugged and hard to access. Okay, so the northern parts of Alberta, okay, much of Russia would have been this biome. It's far away, it's remote, okay, so it didn't get a lot of disturbance. It was kind of allowed to do its thing for a long time. Then we discovered there's large deposits of fossil fuels underneath it. Okay, also big supplies of lumber. So if we can build access roads, then it's going to start getting disturbed simply because we can access it now. All right, wildfires are a big deal. We know that. Okay, it happens here in Alberta every single summer. Okay, there's going to be wildfires in the forests. Okay, and so we get those, and that's because it's a relatively dry biome for a forested biome. And that's because it tends to be either at a high altitude or a high latitude where it's going to be colder and more of the precipitation falls as snow than rain. Okay, because of that, snow doesn't really provide a lot of moisture to stay in that area, right? In the spring, okay, late spring, early summer, the snow melts and it runs off. It doesn't get absorbed into the ground because the ground under it is frozen. Okay, so not a lot of the snow that falls is actually retained as soil moisture. So it's still a pretty dry biome, which is why you see coniferous trees growing there instead of deciduous trees. Deciduous trees need a lot more moisture because every year they've got to make their whole foliage again. Okay, whereas Evergreens don't. Their needles don't fall off. They're smaller, they don't need as much water, right? So you see these typically in colder, drier areas. Okay? All right, so if we're looking at climate, this is a cold biome. Some of the coldest temperatures on Earth can be recorded here. Okay, even colder than you would see, like at the South Pole even sometimes. It can get really, really cold in these biomes. Okay, and that's mostly due to the high latitude, but also sometimes both altitude and latitude. You're going to get a high latitude, high altitude forest. It's going to be really cold. So you can see there, the climate graph is showing that the rainfall's still fairly consistent, but it's much lower. Okay, there's a lot less of it. And you can see that temperature line, okay, we're going down below -25, okay, warmest temperatures aren't even getting above 15, okay, in the summer, so pretty cold. And that's a big swing in temperature between summer and winter, right? So plants have to be really well adapted to that, and they've got to grow fast. Okay? They get 4 months, maybe 5, but probably more like 4, okay, to grow. The rest of the year, everything's frozen. Right? So they've got to grow quickly and adapt to that. Okay? Now the benefit for them, especially if they're a high latitude type of plant, is that when their growing season is going on, what are they getting a lot of? Sunlight, yeah. Okay? They're going to grow in areas that are going to get 16, 18 hours of sun, okay, during their growing season. So that certainly helps. Okay. Questions on the climate? Okay, it's a pretty distinctive climate because you're going to see that lower temperature, okay, but you're also going to see that kind of consistent rainfall. Okay, vegetation, very little diversity. Okay, you walk into a boreal forest and you're going to see white spruce, black spruce, Engelmann spruce, lodgepole pine, Douglas fir. Okay, like that's really about it. Okay, they're not going to be very diverse, and then you're going to have some undergrowth, some bushes and grass. Okay, that'll be about it. So not high diversity, and that's because not a lot of plants are adapted to grow in the conditions that these ones have to endure. Okay, so they have to be drought tolerant. Again, lots of dry times. That's why we get the wildfires. Also, frost tolerance. Very important. Okay, they're going to get frost even during the middle of their growing season. It can easily drop below 0 in the night. Okay, I've had times when I used to backpack a lot, middle of July, and we wake up and we're like, why is it so dark? My watch says it's like 7 o'clock, and then we realize that the tent is covered in 6 inches of snow. Okay, like it can do that any month of the year. It can snow any month. All right, for the soils, okay, cryosolic means cold. Okay, these are going to be soils where permafrost is a problem. Okay, that means they will not thaw very deep. Okay, part of the reason they won't thaw very deep, they're usually not very deep. Okay, usually the parent material is quite close to the surface. Okay, and the topsoil can be quite acidic. Okay. You ever notice around here if somebody's got a big spruce tree in their front yard that nothing grows underneath it? Okay, it's because the spruce tree poisons the soil. Okay, the needles that fall release an acid as they decompose, which of course the spruce tree is tolerant of, but other plants are not. Okay, plus you have its root system there pulling water away. Okay, so it's really unfriendly to anything trying to grow underneath. Okay, but a lot of the soils can be acidic because of those needles.
So we have a lot of spruce trees in our yard,
Mhm.
and so what my dad does is we put mulch beds around, and then we plant like a bunch of spruce trees and stuff in areas, and we can still have like some deciduous trees also growing nearby. Is it because of the mulch, or is that?
The mulch will help,
Yeah.
especially if you get mulch that's a little bit alkaline.
Yeah.
But I mean, you're not planting a deciduous tree right underneath the spruce tree, right? The spruce tree can only really poison the soil directly under itself,
Yeah.
right? Because that's where the needles will fall. It's not going to leach outwards very far. Because you will see forests where deciduous trees and spruce trees are growing together,
Yeah.
But once the spruce trees get to a certain kind of growing stage, the deciduous trees will die off.
Yeah.
It's called succession, but usually that's because of the conditions they produce.
Yeah.
Okay, now, animals in the boreal forest, they have to deal with winter as well. Okay, there's a couple of ways to deal with winter. Stay or go. Okay, lots of animals are going to migrate. And there will be animals that will simply leave for the winter. The animals that stay have to adapt to the winter conditions. Lots of them have a different colored winter coat. Okay, even around here, you can see that the rabbits around here have a gray coat in the summer and they have a white coat in the winter. Right? It helps them to camouflage better with the seasons. Gophers will, well, we say hibernate. They're not really, I mean, they're reasonable hibernators. Their metabolism changes. Okay, is a bear a true hibernator? Like we always say, bears hibernate over the winter. They don't. A bear is not a true hibernator like a gopher or a squirrel. Okay, a gopher and a squirrel, when they hibernate, their metabolism drops. Okay, if you were to like pick up a squirrel or a gopher that was hibernating, it would feel cold and stiff, like you might think it was dead. Okay, because their metabolism drops, so they don't use a lot of energy during the winter. Every once in a while they'll wake up and they'll eat some of the seeds that they hid, and then they'll go back into that hibernation state. When they wake up, they spend about an hour just shivering, okay, trying to get their metabolism and their body temperature and everything back up. But when they're hibernating, they might breathe once a minute, okay? Their heart might beat 10, 15 times a minute, okay? And that's really, really slow for an animal who's got a really small heart and whose heart probably beats at like 200 beats per minute when it's just walking around, okay? So it's a major decrease in their metabolism. That's what hibernation means. Bears just sleep, okay? They sleep, but their metabolism doesn't drop. They burn all the fat they put on during the fall, okay? But their metabolism doesn't change, okay? So a true hibernator has to change their metabolism, and bears don't do that, okay? All right, another thing that animals that stay use to protect them is snow. Snow is a great insulator. We talked about that last week when we were talking about how it had a high or low albedo. It's very reflective, so the albedo is high, okay? So it can reflect the heat back. It's also got lots of air spaces trapped between the snowflakes. That makes it a good insulator, okay? So you can see here, it could be minus 40 outside, but it could be above freezing by 10 degrees in their little burrow. Problem is, if anything compacts that snow, it loses all of its insulative ability because it pushed all the air out, and now it's not an insulator anymore, okay? Fiberglass would do the same thing. If you just squished it like this, you'd squish all the air out, then it's just glass. By the way, don't do that because you'll get a whole bunch of it poked in your hand, okay? But yeah, it'll just squish and then there'll be no insulative value to it, right? So snow is only good if it isn't packed as an insulator, okay? So is there as much food available in the winter?
No.
Especially if you are a herbivore, okay? It's very hard going in the wintertime. Deer will chew on the bark of trees. Okay, and they'll pull the sap out and they'll just eat the sap as it's kind of semi-crystallized as a food source because there's no leaves to eat. You know, if there's deep snow, they can't get at the grass. Right? It's a tough go. If you're a carnivore, it can also be a tough go because a lot of your food might be hibernating. Okay. Now, another thing that animals can do, or there are kind of two different types of animals, are the animals that walk on the surface and the animals whose hooves maybe or whatever go all the way through the snow. Okay, so like floaters and sinkers, okay, as they move through the deeper snow. All right, questions on the animals? What's that on the right there?
It's a marten, I think.
Close. Yes, it's a wolverine. Yeah, okay. And much like the superhero, they're mean. Very, very mean. Okay. Imagine the intensity and anger and violence of a grizzly bear concentrated into something the size of a German Shepherd. Okay, that's a wolverine. Okay, they will literally rip you apart, chew on your bones, and hand them back. Okay, like they're savage predators, but they're not very numerous anymore.
So on par with the chihuahua, that's what you're saying.
Chihuahuas are too small.
I found like most like small dogs are just little balls of rage.
Oh, they have small dog syndrome. Yeah, I know, we have two small dogs, and they both have small dog syndrome. Okay, taken somewhere and there's a giant dog and they start barking at it, it's like, are you nuts? You are punching way over your weight, okay?
Why would you do that to yourself to get two small dogs?
They don't shed, and we have people in the house with allergies, so that's true. Yeah. Can't have a big dog that sheds hair everywhere.
I guess so.
No. Okay, chemical cycling, super slow. Decomposition is super slow because winter persists 8-9 months of the year. It's hard to get any decomposition going if everything is frozen. Okay, so it's very slow simply because, again, the temperatures are low and it can be quite dry through the summer. Again, also not good conditions for fungi and bacteria to start doing their job. There are other animals, though, that can help with the decomposition process. I believe we talked about the carpenter ants back in the biology unit. Okay, they'll get inside of a tree that's died and they'll chew it all up and turn it. They're like termites. Okay, there are northern termites, and they can make a mess of a tree and have it topple down pretty quickly. Okay, Arctic and alpine tundra biomes. We're lumping them together simply because they're very similar. One's simply caused by high altitude, making it cold. The other is caused by high latitude, making it cold. Okay? So about 6% of the Earth's land surface, drastic changes between summer and winter, and that is usually caused by tilt of the Earth. Okay? You've got some parts of the year where there's no sun at all, and some parts of the year where it never sets. Okay? That can make a big difference in your temperature swing from winter to summer. Obviously, plants have to be adapted to that, and there aren't going to be any trees, okay, or very few. Tundra actually means treeless. Okay? And the reason for that is the soils are so cold and permafrost is such a problem that a big tree simply can't put down roots and sufficiently acquire water and nutrients. Okay? So what you see is grass and scrub. It's an Arctic grassland. Okay? Now, so you get an idea here, okay? What's all that stuff at the top of the picture? Oh. This is snow, and it's like a big snowbank. Okay, now, without looking at what year I took that picture, okay, that's July 6th. Okay, still lots of snow? Yeah, okay, so very cold. Snow may persist all year. There's probably places where the snow doesn't melt at all. Okay, you get glaciers and cornices and things like that where it just sticks. Okay? But snow is really important through the winter because snow cover protects the plants from abrasive winds. Okay? If the wind gets blowing, it can really, when you get the ice crystals and whatever going, it can be like a sandblaster. Okay? It's just with ice instead. It kind of makes it worse. Like sand would at least be warm. Okay? But like getting hit with snow that's blowing really fast is also abrasive and it's hard on the plants. So if they're covered with snow, they're insulated and they're protected from that. Okay, so looking at a climate graph for this, okay, we are going to see again that bell curve, but it's going to be low, right? It's not going to get very high. So warmest month would still be less than 10 degrees, so colder than the taiga. Okay, the coldest part probably not a lot different than the taiga. It's still going to be minus 25, minus 30, right? But we are looking at a little bit more precipitation. Again, mostly in the form of snow. Okay? Even June and August, or July and August, that can still come as snow. Right? You might get some rain, and that's why the numbers are higher. But there's also going to be snow any month of the year. Okay, so is it going to be hard to tell the difference between a climate graph for tundra and a climate graph for taiga? Yeah. Okay. What's the big difference? Precipitation. Okay. Not just in amount, but also in
Curvature.
the curve. Right. There's much more of a curve here in this precipitation than there was for the taiga. The taiga was flatter. Forests need regular precipitation. Right, so you're going to have more of a uniform. Even if it's less, even if it's low, if it's regular, that's going to indicate forest. Okay, this does not indicate forest. That's more of a grassland pattern. There's a peak. in one part of the thing. Even though it's an Arctic grassland, it's still a grassland precipitation pattern. Okay, because these numbers are pretty low, right? Like this number here is on par with our precipitation in our wettest month, okay? But this is pretty low. Okay, so vegetation, tundra means treeless, okay? It's defined by the tree line, both by latitude and altitude. We look out here and we look at the mountains, we can see the tree line. That's a tree line defined by altitude. If you keep driving north, you'll eventually get to the tree line defined by temperature or by latitude. Okay, so you can see either one, but the biomes look the same except for the absence of mountains. Right? You just see a flat plain of grass. Okay, if you remember back in the physics unit, the first day I was telling you about the Inuit blanket toss and why they have to do that. It's because there's nowhere for them to get elevated to see further over the horizon. Okay, in the mountains, obviously, you get that. Okay, so vegetation, again, no trees, sedges, so little bushes, maybe grasses, apparently grasses, dwarf shrubs, lichens, mosses, things that are really hardy. You have officially been taught everything in Science 10. Okay, that's the end. Right, you got it all. Okay, so you've got 9 written response. Okay, and you have 25 multiple choice. Okay, the written response is out of 46. The whole test is out of 71. Okay, there's a lot more writing and explaining, like was on the bio test. Okay, application, tell me what you know and how it fits with this situation. There's a lot more of that. There are 2 calculation questions, okay, latent heat and specific heat, both of those would be on there, okay, but the rest is application, explanation, right, like it was in the bio unit. So make sure you're ready to do a lot of explaining. Okay. All right. So for this unit here, first thing we went over, okay, was climate. You need to know the 4 components of climate because, yeah, there might be multiple choice questions that outright asks about that, but also because you're going to have several questions in the written response where you're going to have to talk about components and factors. Now, something I noticed on some of the lab reports yesterday, okay, for the climate graph activity was people got those confused. Right? In the hypothesis, the first part was supposed to be if the components of climate are precipitation, temperature, light, and wind, okay? But I had a lot of people say if the components of climate are latitude, altitude, and proximity to oceans, those are factors, okay? We've got to make sure that we have those things straight because there will be some questions where if you don't have those straight, it will be hard to get any marks. Okay, so we have to make sure we keep those straight. So the components of climate are temperature, precipitation, light, and wind. Weather. Okay, climate is weather long term or average weather long term. So those are the things that would constitute weather. Okay, the factors are the things that affect. What's the temperature like in your area? What's the precipitation like in your area? Light, wind, what are they like? That's because of the factors. Latitude, altitude, okay, proximity to the ocean. Presence of mountain barriers, presence of high and low pressure areas, okay, all of that stuff, okay, those are the factors, all right, so that stuff, you definitely need to know all of those. Okay, ocean currents, I think I left off of that list by accident, but okay, all of that stuff, those are factors. Now, if you recall last week, or sorry, the day before Christmas holidays, I told you, here's how I'm going to test your knowledge of factors affecting climate and components of climate. Map of Canada, an arrow pointing to a city, okay, and me saying, tell me what the climate here would be like. That's where you talk about the components. And why. That's where you talk about the factors. Okay? So the example I used was Okotoks, and I said, spoiler alert, that's not the one that's going to be on the test. Okay? If it was, you would say the climate in Okotoks is that the day length changes, so the amount of light received changes not only in duration but in intensity. The temperature changes along with it. Temperature increases in the summer and decreases in the winter, and can be quite cold in the winter and quite hot in the summer. Rainfall tends to be at its highest, okay, in the summertime because it's on the prairies. And there are Chinooks that occur periodically with winds coming out of the southwest generally. Okay, then you would talk about why. Okotoks has had a high latitude, which is why it's light and temperature change. Okotoks is right next to the Rocky Mountains, which is what causes the Chinook winds, the low precipitation because it's a rain shadow, okay? And then you could talk about, that it's at a high altitude, which can make it colder. Okay, something along those lines. Everyone follow what I'm looking for?
If there aren't mountains, how do you get wind?
Just from prevailing from that mechanism we were talking about, how there's convection that's going like this, but the earth is spinning underneath. Okay, making sense? That's how that's going to be tested along with a few multiple choice questions. Okay, second thing we went over, okay, was climate graphs. Okay, and remember that on the test, that's going to be match it with a biome and explain why. All right, so the first thing you want to do is, this climatogram says the climate's like this. Tell me what the climate graph says about that climate. Okay, then tell me it goes with this biome, here's why. Okay, and in that explanation you can say maybe how the climate graph says that it's close to the equator or far from the equator or whatever would be appropriate. Okay, that's where that comes in. So you probably get, as a 5-mark question, 2 marks for interpreting the climate graph, 1 mark for identifying the correct biome, and 2 marks for your justification. Okay, so what if you pick the wrong biome? Could you still get 4 out of 5?
Mm-hmm.
Yeah, because you can still get 2 marks if you interpret the climate graph correctly, right? And if your justification is reasonable, okay, then you could still get marks for your justification. For example, are the climate graphs for the taiga and the tundra, the boreal forest and the tundra, similar? Might be hard to tell the difference, right? Okay, but if you have some justification talking about this is what is going on here, this kind of fits with this, I might go, you know what, that's a pretty good interpretation. I'm still going to give marks for that. Okay, everyone follow? Now, if I give you a climate graph for the tundra and you tell me it's the tropical rainforest, you're really out of luck there. Okay, because you probably didn't interpret the graph correctly, you definitely didn't get the right biome, and there's no justification to tell me why the tundra's climate graph fits with the tropical rainforest. But if it's close, okay, you can still do reasonably well on that question. Okay. All right, so that's what you're doing with the climate graphs. Okay, match with a biome and explain. Okay, then we had the really long lesson, okay, where we went over heat transfer, okay, all of that kind of stuff, the hydrosphere, the atmosphere, the lithosphere, albedo, okay, that kind of thing. There's a number of multiple choice and written response questions that are going to ask you about that lesson. And they're all going to be application type questions. Okay, so in class, I posed the question to you, how would you design a device that could keep food and drinks cold on a hot sunny day? All right, and you guys told me things like, well, we make it light in color so it had a high albedo and it would reflect a lot of solar radiation away. We'd make sure we insulated it somehow because insulation prevents convection currents from occurring, and air pockets in the insulation prevent conduction from occurring. Things like that. Talk about the 3 methods of heat transfer, things of that nature. Everyone kind of following what we're looking for? Real application, real world application questions. Okay, so energy and global systems. Okay, what are the 3 fates of light? One of them is on the board right now. Okay, what are the 3 fates of light? When it hits the Earth's surface, it can be absorbed, reflected, converted. What's the process that converts it? Photosynthesis. Will I have a question like that? Yeah, okay. In class I told you that's going to be, here's a satellite picture of some part of the Earth, okay, based on the color, structure, whatever, okay, you tell me what's going on with those 3 fates, how much of it's being absorbed. I would mention the word albedo, that would be pretty important, okay, stuff like that. Okay, so that's the three fates. Here are the three parts of the Earth: atmosphere, hydrosphere, lithosphere. Okay, so remember that the atmosphere is the most fluid part of the Earth, so it can flow most easily. That's wind, that's convection. Okay, that can push latent heat along. Latent heat is where the atmosphere and the hydrosphere kind of connect and work together, okay, because latent heat is water vapor. That's actually part of the hydrosphere, okay, but the atmosphere is what helps to move it around. What wind mechanism moves it in particular?
Jet stream.
Jet stream. Okay, that's good. All right, hydrosphere, there's going to be some convection there, okay, but mostly with the hydrosphere, we are concerned with, it's really laggy today. We are really concerned with the water cycle. Okay, and how the water cycle, again, relates to latent heat. Where does the energy go in? Where does it come out? Okay, so the lithosphere, okay, that's where albedo is the most important, because that determines how much gets absorbed, how much gets reflected, and also it provides the soil for plants to grow and do their conversion. Okay, I think that's supposed to be a diagram of insulation inside a wall. If I'm interpreting my own diagrams there. Okay, I think that's what that's supposed to be. Okay, so remember that air can get trapped in between the fibers. Okay, that means the convection current can't get set up because the air is not free to move. Having pockets of air means conduction can't happen because that only happens through a solid. Okay, and radiation, if I can make parts of it reflective, then I can get the radiation to stay in or stay out, whichever would be most appropriate. Okay, I don't know if you guys have ever seen this, but sometimes when you buy small like panels of styrofoam insulation, they actually have foil on both sides, reflective foil. Okay. If I want to bake a potato on my barbecue, okay, we talked about how tin foil's got two sides, right? Okay, some people are nodding no. Okay. Yeah. I'm pretty sure we talked about this, but let's quickly look here. We keep everything back there. Okay, in case you didn't notice, tin foil has two sides. That was grateful. Okay, there's the shiny side, and there's a dull side. Okay, shiny side reflects or absorbs? Right. Okay, dull side? Okay, you bake a potato on the barbecue, which side faces out? Dull side, because I want it to absorb the heat from the barbecue. And if I have the dull side out, the shiny side faces in, which means any heat that goes through it, goes through the potato, hits the shiny side and goes back through the potato, cooks it way faster. You're gonna eat a raw potato if you wrap it the wrong way. Okay, people do. Right. Now, on the insulation I was talking about, they often have like a shiny thin layer of foil on each side. And which side faces out? Dull or shiny? Shiny. Yeah, they want the shiny side to be reflecting, okay, either if it's you're using it in the wall of your house, it's reflecting heat out for the summer, okay, and keeping heat in, okay, on the inside. So that's generally the way that will work. All right. So little things like that, application kind of questions, okay, that could come up. Okay, then we talked about wind patterns. Okay, patterns of prevailing winds. Know that there are trade winds that are easterly. There are westerlies at the mid latitudes that we are in, and polar easterlies. Okay, so know that prevailing winds are usually produced by convection and the Coriolis effect. Right, so hot air rises, cool air descends. That's a vertical movement, north-south, okay, of air. And as the Earth spins underneath that movement, it feels deflected to be from like the east or northeast, okay, or west or southwest, depending on what latitude you are at. Okay, also know what the jet stream is and the role that it plays. We just reviewed that a minute ago, and you guys knew that it helps to move the latent heat around. Okay. All right, so the Coriolis effect, that's what this drawing is. Remember that as air undergoes convection, that's what's going on here. Okay, so hot air is rising, okay, and going this way. Cool air is moving in to replace it, and as the Earth moves underneath that, the air appears to be deflected this way, giving us easterly winds. At the mid-latitudes, it's deflected the other way, giving us westerlies, and at the pole, it's trying to move south, okay, so it gets deflected as an easterly. Okay, so important to remember that, being able to recognize a picture of that and explain.
Do you need to like say specifically like where the wind is coming from, or just that it's getting deflected?
I would say knowing what trade winds are and things like that would be valuable. Okay, specific heat capacity. Okay, two things you need to know about that. Be able to solve a problem using E equals mc delta T, including manipulating it to solve for something other than E. Also, know the role that plays in proximity to the ocean being a factor affecting climate. The ocean is made of water, and water has a very high heat capacity, which means it can gain or lose a lot of energy. That would be warm the air above it or take energy from the air above it, okay, without changing its temperature very much. Okay? That's why proximity to the ocean is a factor affecting climate. Okay, so that's what that is, and obviously being able to use that formula to solve problems. On the test, you will be given any specific heat capacities that you need. Okay, latent heats, again, know its role in energy transfers. Okay, water cycle helps to move latent heat. The jet stream works in concert with that. And be able to solve a heating curve problem.
What is latent heat again? Like what is?
That's the energy, the potential energy stored in things when they change state. Okay, so that's why liquid water at 0 has more energy than ice at 0. Right? It's changed state and has more latent heat. Okay, so remember that diagram, okay, because that's not on your formula sheet. The formulas are, the numbers are, but the heating curve is not. So you need to know the heating curve and where you use which formula. Okay, and the last thing is biomes. Be able to identify them from a picture and description in the multiple choice, and be able to match them up with a climate graph in the written response. That's it. It's a short unit. Okay? Does that mean it's a good opportunity to boost your mark right before the final? Yeah, there's not that much stuff to know here. So one concept could be part of your answer for 3 or 4 questions. Okay, like maybe the Coriolis effect in convection. Well, convection probably ends up in half of your written response questions if it's application. Okay, so if you know the concepts well, you can apply them to those situations really well because you don't have as much to know as you did in some of the longer units. okay? So please take this as an opportunity. I'm not saying the test is simple, okay? But it has less material on it, and that's good for you because you can know that material very well because there's less of it to go over, okay? All right, gives you a pretty good idea what to expect tomorrow. Remember, overdue assignment deadline, it's Thursday at 3:20. Anything that's overdue that you want marked has to be into me by then. Okay, remember final exam, January 23rd, that's Thursday, 9 a.m. Be here for the usual start of school. Okay, things to bring, pencils, plenty of them. Okay, maybe some pens as well, calculator that's fully charged or with fresh batteries. Okay, water or a snack if you want. And then obviously, as you heard this morning, okay, when they were talking about the diploma exams, no phones, no smart watches, nothing that can connect outside the exam room, okay? And do not bring your periodic table, you will get a fresh one, okay? I'm only gonna say that every single day, okay, till the end, so that way if you forget something, I can give you the Nelson. All right, questions on the stuff from this unit? Okay, you have the rest of class to go over the exam review that I posted, okay? I believe it's also the last page of that photocopied thing I gave you the other day, okay? So you can have a look at that. If questions come up, please ask. Happy to help you, okay, work on that today.